In this video, I will be providing you with some design information. I'm going to show you a couple of different ways that you can build a foundation for a house on a sloping hillside or a sloping property. So let's go ahead and get started with our first design. And you can see here where it is stepping up gradually. I have divided the walls here into 4 equal sections, and of course I have the top plates sitting on top of the treated lumber, the top plates, and of course your joist would sit on top of these plates here. Everything would be nice and flat. So we have here a minimum of 6 inches. You would need to check with your local building department to verify what they might actually require. And out here in Southern California, 6 inches is the norm. And you can see here where it is divided into 4 spots. So each one of these walls, each one of these sections are the same length. And of course, you got to make sure that you're going to, whatever you do, you're going to be at least 6 inches, whatever the minimum distance is here also, as well as here. Going to need an access opening into the crawl space area. Anchor bolts. At every break, you're going to need to have anchor bolts, usually within 12 inches of the breaks, and 12 inches from the corners. And of course, whatever the anchor bolt spacing here, I believe this was 20 foot. So these are about 5 feet and 5 feet lengths here. And the anchor bolts usually need to be no more than 6 feet apart. So 2 would probably be fine for a situation like this. Same all the way up. And you can see here where we have the breaks. In between the breaks, you're going to need to have at least 4 feet. Common construction method for framing walls. And I wanted to give you an idea what you would do to attach the framing plate to the treated lumber when you have an anchor bolt in the way. And if that's the case, you might need to notch out the bottom of the top plate here, that is so that it fits over the anchor bolts. So just thought I would throw that out there. So again, a step down footing with our framing plates, 4 foot minimum, basically in length, and they need to be at least 4 feet away from the breaks. And of course here, it doesn't really matter. You know, you can, these are going to be bolted to the foundation. It's not going to be exactly the same as if you have a framing plate with framing studs underneath them. These are going to be bolted. This is basically a solid connection here, and you're putting the wood on top. You could actually just have this brake line up with this brake, and it wouldn't be a problem most of the time. So this is probably the most common method. This is the way I would do it if I could build something like this to save time and money in forming all of the concrete. You're going to save money in pouring, in the cost of the concrete and the rebar, labor, time, materials, you name it, and you're still going to get a nice foundation with something like this. Now in our second example, I'm going to lower this wall here, or the foundation, a little bit lower. Before, if you remember, we had it even with the top of this stem wall here. And just kind of throwing it out here another way if you want to save a few more dollars. And I also want to point out the 2 different corners, if we can focus on. I framed them or built them differently. So on this one here, we have the sloping surface, and it's going all the way to the corner. So, this has got to be 6 inches here, but this kind of provides us with some protection of the if we get snow or something that built up against the corner here, then we're going to have a little more concrete, and the wall goes all the way to the corner. And I just kind of showed you how I would frame it here. Put some treated lumber up here, run a block across here, Give you another view of it. Of course, the studs are going to be longer. The opening does not need to be this tall. I think the minimum access is 22.5 by 22.5 for something like, for a crawl space. It might be 30 by 30. But again, you got to check with your local building department. Get a view of this one from the outside. And you can see here where we brought the foundation back a little bit. And of course, over here it ran past the lower wall. And here you can see what I'm talking about. And as long as we're going to have our 6 inches, our minimum space here, this shouldn't be a problem. Something else you're going to need to consider with this is how you're going to finish the outside of the building. So here you can kind of see we're still good as long as this point is 6 inches. I do like the other method over here better, but if you were going to finish this somehow, like let's say you wanted to have your siding or stucco go all the way across, and this might not be as big of a deal with stucco, but if you wanted to have your siding, you might not be able to nail it into the concrete here. This could be a problem. Something like this, you could finish this whole wall off with siding and even put some trim around the corner here, if that's the look that you want. I mean, the whole thing about planning all of this stuff is to actually take the time and consider as many possible problems or design issues while you're designing the building and eliminate those after the fact. And of course, concrete, we all know, is unforgiving. You can't really just go in and say, oh man, I should have did this over here. And keep in mind that this is an example that you could use on both sides. And this is an example you could use on both sides. I just saved myself some recording time and drew both of them in here at once. You wouldn't build a house, I should say most of the time, where you have a situation like this and then a situation like this. It would be either one, this on both sides, or this on both sides. And of course, same here. If you were going to use this method here, you would put it on both sides and the solid concrete wall on both sides. Again, just throwing out some different ideas. This right here, we actually divided in half. If we were to measure the length of the top of the wall here, let's say it was 20 feet, this would be 10 feet. So this would be half. If you didn't want to split it up into 4 sections, you just wanted to split it up into 2 sections, it would look something like this. And again, the reason for doing this would be up to you. You know, I already provided you with the first examples, the one I would probably use for this, but you might have your reasons. Your architect might have the reasons for doing something like this. And even your contractor might have their own reasons. So again, the wall stopping here, if we were going to finish it with siding, maybe this would be the preferred method over this one here. And stucco might not be a big deal. And of course, you're probably going to want some anchor bolts to bolt this framing stud to the foundation. And if you're worried about, this is where I get a little creative in my framing, just to have a little block here and then have the wall finish over. No, use a piece of treated to as your top plate that you would normally have used construction standard lumber for. And, that way you got your treated lumber that's separating the framing lumber from the concrete. So just something like this be a good idea. And bolting everything together is nice. That's always a nice idea. So again, another method here. Now let's go ahead and take a look at our last method. This would be a solid concrete structure. And again, if this works for you, great. You're going to need an access hole in here. And I would imagine this would be the most expensive, but probably the strongest at the same time. And of course, your engineer might veto all of them. Your engineer might say, no, this is the only way that you can build something like this. We're not going to give you any other way. And that will be the end of that. So anyway, that brings us to the end of the video. I hope it helps. And hope it gives you some ideas on how to build something like this and help you with your building foundation if you are going to build something on a sloping surface.